Today's video is all about the periodic table and the beginning of it. So, the first thing is we need to talk about the scientist. Mendeleev arranged the elements in order of increasing atomic mass. He was a teacher. He was trying to get his students to understand the elements, and so he tried to base it off of the game Solitaire, which in Solitaire you have to put cards arranged based on a certain order. So he was trying to do that exact same thing. So he took all the different elements that were known at the time and looked at their properties, and based on those properties he tried to group them up. So he put them in the order of atomic mass. With that, he then made predictions. With the help of his periodic table, he was able to predict properties of 3 unknown elements. So for instance, they had discovered aluminum, but they had not discovered an element that was supposed to be below it based on his table. Later on, when gallium was discovered, the properties of gallium matched the ones that Mendeleev predicted. But occasionally there seemed to be an element out of place. Properties were not similar. So if you look very closely at your periodic table, if you look at the masses, most of the time they are still in order of atomic mass. Occasionally, for example, number 52 and 53, Te is 127.6, iodine is 126.9. So there's an example of where it's not by atomic mass anymore. So something had to change because it wasn't correct. So then the change happened. Mendeleev designed his table before scientists knew about the structure of the atom. So they didn't even know that elements had unique number of protons. So they didn't know an atomic number at the time. So then the modern periodic table is now arranged by the atomic number. So this is what you need to know. You need to know how Mendeleev arranged it, and you need to know how it's arranged now. You should be able to tell me both. So now it's by atomic number. There are groups versus periods, the same thing as columns versus rows. This is the thing you've got to understand is groups are your columns, periods are your rows. So elements within a column, which is your group, in the periodic table have similar properties. The properties within a row, meaning your period, change as you move across the period from left to right. Now I'm going to add some things to this slide that you need to add to your notes as well. So with this, you have a couple things. So this is what you've got to understand. The elements in the same column have similar properties. So if I were to ask you, looking at your periodic table, you need to have out your periodic table. If you don't, pause the video, get it, and come back to me. If you look at Na, sodium, and you compared it with Mg, which is beside it, or K, potassium, which is below it, which one does it have similar properties to? And it's all, the answer lies within this sentence right here. Na would be more similar to potassium. So if you compare Na to K or Mg, which one would it be more similar to? The answer would be K, because they are in the same group. So I could easily make that a multiple choice question. What element is similar to what element? And your answer will always be the elements that are in the same group, all because of that. Now, they have similar properties for the following reasons. You need to write this down. They have similar properties because they have the same number of valence electrons. So pretty much, properties are determined by the number of valence electrons. This is why they have similar properties, because they have the same number of valence electrons. Everything in group 1 has 1, everything in group 2 has 2. We talked about that when we went over electron configuration. Okay, so the period it changes as you go from left to right. So no telling what's happening on that row. The thing that you've got to understand about the period is that the valence electrons are on the same energy level. So the period number, and we talked about this last class or last unit, the period number is the number of energy levels. So row 1 has 1 energy level, row 2 has 2 energy levels, 3 is 3, and so forth. So the period number tells you the number of energy levels. Periodic law: when elements are arranged in order of increasing atomic number, there is a periodic repetition of physical and chemical properties. Pretty much you just need to know the definition of this. And it sort of should make sense because periodic repetition of physical and chemical properties. We will be doing a project with this unit, building your own periodic tables based on anything that you want pretty much. You now need to pause the video and color in your first periodic table based on the picture on the board. The picture is showing the differences between the representative elements, transition metals, and the intertransition metals. You should be able to tell me, if I give you an element, which of the 3 it is. You are now going to color in your second periodic table. This periodic table shows you where the metalloids, metals, and nonmetals are. Also, be sure to color in the staircase that's provided. Please pause the video and do this now. You now have a chart that shows you the metals and the nonmetals and metalloids. Please pause the video and write down the following properties for each one. You should be able to tell me these properties. The next periodic table, you will color in the following families: alkali metals group 1, alkaline earth metals group 2, groups 3 through 12, the transition. The gray area are your other metals. Group 17, halogens. Group 18, noble gases. The bottom are your anthonines and actinides, which are also known as your intertransition metals. Please pause the video and color in now. You now have a chart that has all the properties of the families that you just colored in. The main ones are the last 3 columns that you need to know: electron configuration, reactivity, and charge. So for example, if an electron configuration ends with 3s1, then you should know it's an alkali metal. The N just stands for energy level. Alkali metals are the most reactive metals. Halogens are the most reactive nonmetals. Noble gases are non-reactive. Then the charges, which we will go into more detail next unit.